All right, limit process, proof for question number 35. And it says, given that f of x is equal to 1 over the square root of x, use the limit process to find f prime at x. So first thing I do is set up our opening statement here, and that is that f prime at x is equal to the limit as the change of x approaches 0 of, right, f of x plus change in x, so it's 1 over x plus change in x. Why did I do that? Because it says, right, we're using that process, and the first thing I'm going to do is replace this piece. So where I found an x, I put x plus change in x minus f of x, and f of x is 1 over this, so 1 over the square root of x all over the change in x. Okay, from here it took me to figure out what I wanted to do here because there's a couple possibilities, but what I decided to do was multiply here. I'm going to multiply here by, square root of x plus change in x. Look at this way, multiply this by square root of x plus change in x. And if that's throwing you off a little bit, look, this is the same as this, isn't it? So, all right. So I multiply that, and I have to rewrite the limit process here. So the limit as the change in x approaches 0. Don't have to rewrite f prime at x again. And we would get, square root of x times x plus change in x, right? I'm taking this over here, all over square root of x plus change in x, right? This minus sign is this one, minus square root, right? This times 1 is square root of x plus change in x, all over square root of x, all over change in x. So if you can see what happened here when I did this is I got to cancel out a bunch of crap because it just got to be a bunch, didn't it? So what's going to cancel is this. This is going to cancel this, and this is going to cancel this. So I'm going to simplify a little bit. So simplify. So I'll simplify this out a little bit, and this cancels, so this, and this remains. That gives us the limit as the change in x approaches 0. Your professor is going to expect you to write this notation over and over. So is equal to limit as square root of x minus square root of x plus change in x, right, all over change in x. Okay, so here, hopefully here you have some strategy, and hopefully you're seeing that we're going to use the conjugate here. And the conjugate, we're going to take the conjugate of this piece up here. So of course the conjugate of this is a and this is b. If it's a minus b, we use a plus b. So we use the square root of x plus square root of x plus change in x all over square root of x plus square root of x plus change in x, multiplying by 1 using the conjugate of the numerator. I'm going to, what am I going to do? We know this. The reason we do this is because becomes difference of squares, doesn't it? So if you did FOIL here, and not going to do it for you, but if you do FOIL here, you know you would get x, right, minus x plus change in x is what that would simplify out to, all over this change of x, right, times x. Oh, look what I did here. I missed this part here. That's what the problem I'm having is. So is x plus change in x, right? Then times this conjugate. So times square root of x plus square root of x plus change in x. Right? This one right here comes from here, and this one right here comes from here. Sorry about that. You see it? Okay. So I keep working. Forgot to write limit here. So limit as the change of x approaches 0. Simplify this out. Distribute this into here and here. This becomes the limit as the change in x goes to 0 of x minus change of x. Look at this is all starting to come together, isn't it? Because look at this change of x is this one right here, isn't it? And then times x square root of x times square root of x plus change in x. I know you're probably going to be tempted to do something with this, but just hang on because it kind of takes care of itself. You'll see in just a second. X plus change in x here again, isn't it? Right? Now hopefully you can see that these two cancel, and that leaves us with negative change of x. So I'm going to skip some of this crap here, and there's your negative change of x, and negative change of x over change of x is equal to negative 1. So that equals the limit. So change of x approaches 0 of negative 1, right? Because this and this go to 1, don't they? Of times square root of x plus change in x, right? Times the quantity plus square root of plus change in x. Believe it or not, we're almost done. It just looks like hell here, but look at it for a second. Remember the deal here. At the very beginning, way up here, we have that change of x value in the denominator, and it's a factor of the denominator. And if we let the change of x, because that's our ideal outcome here, is to let the change of x equal 0. If we did that up here, we'd have it would become undefined. It wouldn't make any sense, right? But look what happens now if you let change of x equal 0. Look what would happen. So let's try that. Let change of x equal 0. See if it creates a domain issue. So this would become 0, right? This would become 0, wouldn't it? And square root of x plus 0 is just the square root of x, isn't it? So that becomes square root of x, doesn't it? Square root of x plus 0 is just the square root of x, isn't it, if you think about it? All right. Now, just a little bit of stuff here. Square root of x times the square root of x, of course, let's just rewrite. So we're going to take this limit, negative 1. Square root of x times the square root of x is the square root of x squared, which of course is just x, isn't it? Times, and then look, we have 2 square roots of x, so 2 times the square root of x. Now, a lot of people would leave it this way. I don't know what your teacher or professor says, but one possibility is to do this, is to say, well, the square root of x is equal to x to the 1/2 power, isn't it? So if we did this, we'd say is equal to negative 1 here, right? This 2 is this 2, and x, this is x to the 1st power, so the 2 over 2 power. Because remember, this is rules of excellence. We add their we add their exponential values, so we get x to the 3/2 power, which could be written as negative 1 over 2 square roots of x cubed. Wow, right? So there's our answer. Okay, you guys, really, really solid work. Let me know.